Hi there. We're back.
Yes, we're back.
That was an awfully short break.
It was a short break, yes. So we now have a very, very special guest here. We are honored to have NASA's Associate Administrator for the Science Mission Directorate, Dr. Zurbuchen here. Dr. Zurbuchen grew up in Switzerland. He earned his doctorate and Master of Science degrees in physics from the University of Bern in Switzerland. He has served on and led innovative scientific teams that have helped enlarge our perspective on the solar system and the universe. He was also professor of space science and aerospace engineering at the University of Michigan in Ann Arbor. During his career, Dr. Zurbuchen has authored and co-authored more than 200 articles in peer-reviewed journals. His honors include multiple NASA Ground Achievement Awards, induction as a member of the International Academy of Astronautics, and NASA Outstanding Leadership Medal, and many, many more. Welcome to Yuri's Night, Switzerland, Dr. Thomas Zurbuchen.
Hey, hi, how are you doing? Good to be here. Is my picture okay, or am I all distorted? Just let me know.
No.
It's fantastic like this.
Yeah, can you submit that on? Hello.
It's really an honor to have you here. And of course, all eyes are on Mars right now. On February 18, Perseverance landed on Mars. How did you experience the landing?
So needless to say, I'm extremely proud of the team, the whole Perseverance team. I just spent, frankly, 4 days with a large fraction of them, including one of the nights, going to work, as they say, at midnight, because Mars night is, Mars day is right now offset from the night. And of course, I was in California and hanging out with them. And actually during the time of Yuri's flight, I was right there with the team. The way I experienced the landing, of course, is a little bit different than many others. It's kind of, the way you should think about it is kind of, in my job, you take your whole career in your hand that day. And of course, you hope it works and trust that you did everything you could have. So I was very nervous that night, and of course, elated and just excited. Once we got these kind of initially low-resolution pictures of the new neighborhood Perseverance was in, right there on Mars. So it's just absolutely fascinating, fantastic. Also being together with my friends, including the managers and some of the top engineers.
You are a researcher yourself, and as you said, as the NASA science director, however, you can only watch. How difficult is that for you, and doesn't it sometimes tempt you to take a hand yourself?
Yeah, so I think that's a very thoughtful insight. To some extent, I'm a hardware guy, so I'm always happiest when I'm standing next to hardware and in a lab. Frankly, everybody knows that if they want to make me happy, they put me into a lab when I visit. I also like meeting people, not just the top person. I spend a lot of time with technicians and engineers, because I think that ultimately that's where mission success is being created. So what's important, though, is that we all recognize what our jobs are, right? So for me, the most important piece relative to perseverance and ingenuity is to create the environment in which both could occur. That required a lot of things. For example, it required the right budget rollout. It required the right leadership. It required a very transparent communication, which I did not find when I went to NASA. And we ended up in a place that was so trusted as a team that we could get through Corona without really making a major impact. I don't think, if Corona had happened 2 years before, I don't think we would have been able to do it as a team. And of course, that credit goes to the team. So I'm a leader, and I'm not a doer. I do not touch hardware and so forth. And frankly, I'm usually not the smartest guy in the room either. That's also important to recognize. When that's the case, I will not generally find the technical solution, but it is my job to create the environment and also, frankly, protect the team also from the up and out, so to say.
The Perseverance rover has been on Mars now for roughly 2 months. What are the highlights it has delivered so far?
Well, so the most important element, of course, is that the rover has been started. Kind of a lot of the subsystems, the instruments have all basically been ramped up. Recall that these instruments are really complex. We have missions in the Science Mission Directorate that are cheaper than some of the instruments. So some of these instruments are very complex and first of a kind. And so we've all started them. We're basically making progress on all of them, getting data. I was as part of the night that I just talked to you about during Yuri's night, that specific anniversary time. I was actually a few hours later, I think it was 4 a.m. that time, I went to a science meeting focused on kind of atmospheric sciences, which is some of them. So again, the rover, basically the team is getting to know the rover. We're learning how to drive. We have, of course, dropped off Ingenuity. And as we're getting this ready to fly, we're basically starting to really exercise our muscles in all dimensions, the arms, the imagers, but then also, and equally, most importantly, the instruments. And so we're basically within kind of after the month of Ingenuity here, we're getting ready to go on a journey and go drive and collect those samples, which of course every meter on the surface of Mars is a meter of sample return. That's what we're going to do.
You mentioned Ingenuity is ready for the flight. For now, as I read, the flight will happen no earlier than the next week. Are you nervous about this?
Less so than when we landed Perseverance, and the simple reason for it, and I think it's really important that everybody understands that this is a high risk, high impact venture. So we spend a much smaller fraction of money on it, and we're taking a shot on goal from midfield, right? So you don't always win that way, but that's what we're doing, and we're doing it not just with Ingenuity, we're also doing it with Moxie. Now, it's really important to know for everybody, and you see an indication of that. We did not test Ingenuity to the same level of detail as we tested Perseverance. We told everybody we didn't, and I don't know whether you've seen, but we just released kind of on Twitter answers to many questions about this, and that's what I'm really stressing. I mean, everybody needs to pay attention. NASA wants to be a place where we also take some of these shots on goals, and frankly, we're very unapologetic for the tech, the slight software issue we found. I wish we didn't have one, but frankly, there's absolutely zero negative feelings against the team. This is exactly what we wanted them to do, is to sprint, and not some kind of go do this for 10 years and spend $1 billion on it. We couldn't do it that way. It's a different way of running, right? Kind of when you do these tech demos, and that's what that is. I have every belief that next week we'll fly and it will be successful. The team did do the preparation. I spent quite a lot of time with Mimi on, who's deeply inspiring and a strong leader, and I believe her team will be successful.
After the flight, you landed in a very special place, the Jezero crater, which hopefully holds a lot of interesting stuff. What are the next steps after the flight for Perseverance mission?
Well, so we're basically charting out the whole path, right? It's gonna, we landed something like 1.9 kilometers away from the kind of what used to be the watershed, right? Kind of the water getting into the crater there from that ancient river that came down the mountains, and so we're right ahead of a dune field. It's not, like just look in Switzerland about how these things look, right? It's not surprising. Water came down and brought all kind of dust and rocks and sand with it, and then dropped it there. So there's dune fields ahead of us to where we want to go. So we have charted 2 paths around these dune fields, and we're going to start driving on one of those trajectories. And frankly, I'm not making that decision. That the rover team needs to do that together with the science team. So we're going to go do that and really use the extra speed. We build perseverance for more speed. So we can, as compared to curiosity, 3 times more or so. And so, more autonomy. So we're going to go do that. We'll also, frankly, there's already amazing science happening right now. We're going to, before we start taking off, we're going to tell you some about the science we're learning, including deposits that are kilometers away from that river entry into the crater that show that there apparently was much more violent water flows even kilometers away. So it's so we're there's interesting science that's already coming, but make no mistake, where we're going is towards that river entry, and then collect those samples, because that's what our key mission is.
Under your leadership, dozens of science missions are on the way to explore our solar system, the Sun and Earth. And in addition, there are many new missions in the planning stages. Which current and future missions are particularly important to you, and why?
So the most important mission this year, so we have 8 launches this year, and the most important mission this year, I would say, beyond the landing we just talked about, is James Webb. And I just want to tell you, I just checked on the team again, and we're on track for our end of October launch. We'll see how it all goes. Remember, the Europeans are launching that, and it's kind of funny that the guy in charge of that part of ESA is another Swiss guy, which is Daniel Neuenschwander. I'm sure you know him. We talked about we can really destroy it for the whole Swiss professional corps here if we mess that one up. It's kind of 2 Swiss guys kind of being taken out by a spacecraft. Anyway, and the Swiss company, by the way, with Ruach doing the fairing, which you saw has been in the news too. Anyway, the bottom line is that telescope, of course, is the most complex mission we've ever done. The investments will be close to $10 billion total. Just for comparison, it's roughly a third or less, a third or less investment for Perseverance. So it's a very massive thing. Over 300 single point failures that need to all work, right? So it's just for comparison, the Perseverance is 80. So kind of in the landing stages. So it's going to be nerve-wracking, but the promise that it has is incredible, right? Imaging the first galaxies in the universe, and frankly, you start like with this Big Bang with mostly hydrogen and some helium, and then eventually you end up with people with platinum on their fingers and so forth. How does that work, right? The answer is you need to make a lot of stars, you need to make galaxies, and especially the first generation of galaxy, and we don't know how that works, and that's what we're doing. Exoplanet research is going to be really critical, including the great work that's done in Europe, of course, with various missions, but the one out of Switzerland as well. And then, so that is James Webb. For me, the biggest kind of, at the highest level, the biggest kind of next highest priority after Webb is sample return. And again, as an international entity, it was really important to me that we actually build sample return before we land Perseverance. And the simple reason is you don't know how to run the mission on the surface of Mars if you don't know how you bring it back. It's one of those system engineering things. You need to put constraints on the return, and so that's what we're doing. There's many others, but those are the 2 I would point out.
You studied at the University of Bern and know the Swiss space research sector and its industry from an international perspective. How important is Switzerland in terms of spaceflight and space research? Yeah,
so in kind of with boxing language, Switzerland punches well above its weight, right? It's doing really well. I mean, of course, Bern has a long history. And I just want to tell you, the only reason I went to Bern is it was closest university to Heiligenschwendi, which is where I lived, right? So, and I thought I couldn't afford anything else. Only later did I realize I could have gone to Zurich, which is fine. I like Bern and still like it a lot. But the point is, Bern has been there, and I think the university has frankly put more effort on it, and rightly so, based on both the planetary science and the astrobiology, which I think is a really kind of a field that will be with us for decades. I think it's just absolutely critical. But you know, don't miss the fact that, you know, important things are happening in other places. You know, I know, you know, of course, you know, what happens in Zurich around ETH with, you know, some of the electronics, also some of the really advanced systems they're doing, but then also in Lausanne, Geneva. And there's other units that, even in Lucerne, other places, other units that are doing really well. My personal feeling is that, and my observation has been that Switzerland is a welcome partner in the international scenes, and it's welcome for many reasons, but one of them is it's highly reliable. And I think the talent that is doing the work in Switzerland is of highest quality, right? And that turns out to be a really important part in the space business, that you can trust the technician that soldered the board, that it's done the right way, because it turns out you get stuck. I mean, I know of a bunch of soldering problems at my level in whatever country or whatever region, right? And so for me, it's, you know, what I like about Switzerland, I think what people like across the board, whether it's with our friends at ESA or at NASA, is that we're deeply aware and excited about the quality that Switzerland brings to bear. Of course, the tremendous research as well. I'm just going to add one more point, and that is that there's important work in earth science going on in Switzerland, earth science in and from space, and in various places, University of Zurich, ETH Bern as well. And I think that, and many others, but I just think that is also an increasingly important part, and especially a country that is affected so much by climate change as Switzerland. I think that's also a growth field, and I believe that Switzerland will benefit from, and that the Swiss workforce will benefit from the direct experience from, you know, how mountains look, how water bodies look, and, you know, how you image them in various environments. You're muted.
Guido, you're muted.
Funny, sometimes they want to stop me. Following our conversation, we will talk about the current call for astronaut applications by ESA. We will talk with young astronaut applicants and our Swiss astronaut, Claude Nicollier. We are aware that you are not responsible for NASA's human spaceflight. Nevertheless, how high do you think the chances are that a Swiss astronaut will be on a flight with a Crew Dragon in the foreseeable future?
So if there's anything this team can do here, is to dial that up on the inside of the country. So because I think what Switzerland does at the political level is the most important predictor for that. I have every belief that there's great talents from Switzerland, including the ones that you're going to talk to. Claude Nicollier is one of the highest quality astronauts NASA has ever worked with. I know that not because, of course, I'm biased because of my youth and considering him a hero, but because I talk to many people who know him personally and have seen him in his training and in his work. And so for me, Switzerland can do that. The question is it a priority? And I sure hope that Switzerland is not missing that opportunity and really pushing that forward, because I was trying to tell you, I was inspired by Claude Nicollier personally, right? I turned out to be a scientist and not a pilot, you know, like Claude, and I envy him for that still. You know, I fly tiny little airplanes with like engines that are, you know, not even close to the kind of stuff that he used to fly, but, you know, I used to fly at least. I don't have time right now, but you get my point. There's different careers in space, and I think some of the careers will be charted by people here who are on that are not careers that were available when I was in school. And you see, my life is also a career that's not available when I was in school. Kind of the point is, there has never been an immigrant doing that kind of work at NASA, right? And so who would have guessed that that's a possibility? And just for me, what I really hope the good people here, the 180 or so individuals who are on this call, right, really, you know, voice that they think Switzerland should do that, and do it from the point of view as being a powerful voice for innovation and leadership for this country that you know, has given so much to the world.
What special advice would you give to young astronaut applicants and young space researchers?
Well, just do it, right? I mean, and for me, that, you have, I mean, growing up in Switzerland, I mean, I went to Switzerland, I did, my diploma, and then, which I think they call now masters, in physics, and I built a part of a spacecraft that is still flying. I did that in Switzerland. I actually don't know many people in the whole world as part of, I came from the, normal mandatory military, and I walked into some guy's office, and the guy said, yeah, well, I mean, here's a diploma, but it's too hard. And I'm like, I want to hear about it, right? So I built this thing with the technicians there, and I tell you, I'm still benefiting from that. The opportunities you get in Switzerland are second to none, even if you go through other trajectories, right? Go be an apprentice, perhaps to one of those amazing engineering schools that are also around. I just think, just do it. I mean, Switzerland has a lot of options, and never think that somehow the size of the country says anything about you, other than it's one of the most beautiful countries and it happens to be small, right? So for me, that don't that attitude, that somehow predicts what the opportunity space is just not reality. That everyone here, needs to know that I have all the opportunities of the entire earth available for them. Whether they're in the US, whether they're in Switzerland. I know super successful people in Switzerland. The president of the University of Zurich, super successful guy, startup entrepreneur, works with NASA. I mean, he did a different career than mine. I think I consider him equally successful. I mean, look at the amazing stuff he's doing. I'm just picking out one. I could talk about my buddy who studied with me in Switzerland and is running a startup in Zurich. About another one who's running one in Thun, right? So for me, those are trajectories and some in San Francisco, right? I mean, my point is, you have all options. Don't ever think differently.
Dr. Zurbuchen, we know you have a tight schedule. I guess we have 1 or 2 minutes. Is it okay if we have questions from the audience?
So I can go till 40 if you can.
Okay.
Till 40, and then I need to jump off because I need to give another talk somewhere else, but till 40.
But
okay,
I think we have some questions from the audience. Maybe Miki, you have an overview about that?
Yes, we have some questions about Perseverance is busy at the moment going around, and it's going to be making all these caches and dropping them off in bundles. And we're very curious to know what sort of plans are there for picking them up in the future.
So we're actually working with the European Space Agency on just that right now. I'm spending a lot of effort on it. Both of us have managed to secure funding for that. And, David Parker, my close friend who's running that program in Europe, is a British citizen, of course. We're working on that. So our plan is going to be that either in 26 or 28, we're going to take off with 2 spacecraft. One of them is going to go into orbit. One is going to launch on a European rocket, and it's going to go into orbit on a slow trajectory. One of those low thrust trajectories, going to go into orbit into Mars and let itself down, right? Kind of cutting off and basically be there. The other one will take off from the US, and its most important payload, besides a small rover that's built in Europe and Canada, besides the most important payload is a rocket. And we're going to precision land it close to one of those stashes, or by the rover, if the rover is still alive and well, and we're going to land it there, and then we're going to collect those samples with the rocket. Something like a few months later, over a year roughly later, we're going to go into orbit, and I think of it like an Easter egg. So it's a sample container. We put it in orbit around Mars, and the European spacecraft is going to scoop it up. The Austin Powers movie. That's precisely what we're doing, except in real life, right? Scooping it up, and then we come out, spiral back out using that ion thruster, and then come back and drop off the samples on a US-built part that was hanging from the European spacecraft all along, and drop it into Utah. So that's what's going to happen between the time frame of 26 to 31. So that's what we're working on right now, and there's already hundreds of individuals all over the world working on it.
Sure. And there was a further question also about that what concerns, over that amount of time, if there's accretion of sand or dust being blown onto the caches. This could create another challenge to overcome of how to extract them. Is that a something? I mean, I guess you must take it into consideration.
Yeah, so we've thought about this. We know how much we know how much deposits there are, and we know what's really important, and we know exactly where they are. So that's what's the most important thing, is to really locate there. Then we'll find them. But we actually don't think that they will be covered up based on the deposit rates that are there. Of course, we don't know everything about Mars, which we're reminded every time we go there, right? But the point is, we have a robust plan. Miki, what's really most important in these plans is they have robustness in it. So if new things happen, we're ready to deal with it. So we actually, as we collect those samples, we have two possibilities we're already building in. The first one is to go pick it up with the European Fetch rover, but we already have a reserve element, which is where Perseverance itself, right, also carrying samples. So we have two options. So the same is true with the location. We're planning it. We know how to pick it up, and even if they're covered by dust, we know how to find them.
Mm-hmm. I guess it's almost a simpler matter than the samples or the unknown terrain that you are facing. At least you know the exact size and shape of what it is you want to pick up.
Yeah, exactly right. And what we're trying really hard to do with Perseverance, right? That's why we have such sophisticated instruments. We can locate them using imagery and really good maps from orbit as well, right? So we know exactly. I mean, we know down to a fraction of a yard where these samples are, right? So it's not. So we know where to find it, and that the wind is not strong enough that it will carry a sample, right? I mean, that's just not, I mean, we know we actually have measurements of weather parameters on Perseverance, as we do on Curiosity and some on InSight. So we know about the history of that. So yes, it could, deposit dust, but we can handle it.
So then this makes me think rather a lot about the much longer term planning, that when the Perseverance probe was being designed in the first place, you must have had to try to write specifications for what the caches would look like with the further missions so far down the line in mind, without knowing what would be developed further. Roughly how long ago, I mean, how does this timeline go? Because it's such a long trajectory, and you don't know, I mean, first of all, you don't know whether the Perseverance mission is going to be successful. So how do you plan out your planning of what technologies you will need and what you are hoping that you will be able to utilize on the next round?
So whenever we plan for success, and we protect ourselves against failure. So in other words, that Perseverance was built, was started almost 10 years ago, right? And so basically what the good people did who were there, by the way, I was not in the room, I was a professor somewhere else, right, in some other organization. But the point is, what they started to do is figure out what a robust sample container would be. And I had just went for drinks on, I think it was Saturday, with the guy who designed that, right? It's a really inspiring guy. It's like, how did you come up with the number? And it was the robustness arguments that you just mentioned that were there. What we then did, something like 5 years ago, we started really imposing designing the sample return the way it is right now. I mean, I really felt it was important, not so much because of the hardware, but because of how we do the collection of the samples. That campaign needed to be matched to how we're going to pick them up, right? Yeah. And so basically that's why it was important to start that campaign. And so I think we're going to be hand in glove. And yes, there's uncertainty, and we have to. I mean, we're worried about a lot of stuff. Like if you have a job like mine, you're always worried, right? That's your job. So one of the things I'm discussing right now is what's the robustness of the communication architecture, for the next few years. Of course, we're using Mars Reconnaissance Orbiter, some of the European assets. Like how robust are these? Do we need to move some of these spacecraft now to be sure that in 4 years we have the right comm architecture? So that's just one of them. There's many others. There's going to be surprises with Perseverance, right? I mean, there's always surprises. It's just the way it is. And what we're going to do is just learn, kind of use our amazing team, our international team, to solve these issues and move forward.
Yeah. Thank you so much.
Maybe the last question. There was a question about how your average workday looks like.
Well, I wonder that myself sometimes when I'm in there. But basically what I try to do is, first of all, I don't work 20 hours per day, and I think and the reason for that is my job is I think of it more like a marathon, not like a sprint. So you need to find the right speed so you can actually go for a long, long time. And so what I do is I come to work early, probably after, usually I go to the gym in the morning. Since COVID, I put the gym in the middle of the day because I can't stand looking into a monitor for 8 hours straight. It turns out I just don't know. I cannot do that and be focused. I learned that about myself. I did not know that. So I put the gym there. But anyway, I go to work, and then we have usually a team meeting trying to figure out whether there's any urgencies. We have 100 missions. Basically, every issue that comes that is putting in question any one of those under development and so forth comes to me on a daily basis. And then what we spend time on is decisions that are based on missions. Often these decisions get delegated down. The goal is not to make all decisions. The goal is to only make the decisions that you have to make. And then part of the day are in meetings or in discussions about strategic change, like what should be the next generation. We got to Mars sample return because we did the right discussions of that. Sometimes that requires traveling. My job, as the head of the science program, is also up and out. So I spend quite a lot of time with congressional members or members of the White House team, trying to really make sure. And of course, I'm nonpartisan, deeply nonpartisan, but the job is to explain to both sides of the political spectrum, or all sides, I want to say, of the political spectrum, what we're doing and why what we're doing is important to the nation and to the world. And so I spend a lot of time on that. So just think of a day that has some operational pieces, some strategic pieces, but a lot of communication.
Thank you so much for answering all these questions, Dr. Thomas Zurbuchen. It was an honor and a pleasure to have you as a guest of Yuri's Night Switzerland 2021. Thank you so much for being with us, and good luck with all your missions that are coming, and good luck for the helicopter on Mars.
Yeah, thanks so much, and thanks to the team that organized this. I think it's really important, and I couldn't be more supportive of your efforts. Go make sure that the Swiss select, push an astronaut from around from your side. If there's anything I can do at my level, let me know, okay?
Yeah.
All right, talk to you later.
We have one of your colleagues speaking with us next. This is Christine Corbett Moran. She's on a few minutes later.
Yeah, she is great. I saw it on Twitter. She tweeted at me, so I'm sure she's going to be just amazing. Thank to her that she's speaking here also. Okay.
Thank you.
All right.
Thank you so much.
Thanks so much.
Bye.
Thank you. Take care.
So Miki, it's your turn.
Oh, my turn, actually. Well, my turn is actually to now introduce you to, sorry, I will just multitask, but I'm not very good at multitasking. Okay, so now it's time to introduce you to the one and only Professor Claude Nicollier. And actually, I think probably everyone in the audience knows very well who Claude is. He's Switzerland's first and only astronaut. And Claude, I don't see your face on the screen. We have so many guests that I am scrolling through, trying to find.
I'm here. I don't know. I should be visible, no? Am I not?
So we have many, many guests. Okay, now I will add a spotlight.
Yeah, I can see everyone. I can see you. I can see Guido. I can see Tatiana. I see everyone. Rodi van Klik. Actually, it looks like you don't see me.
Yes,
yes, we can see you.
Okay, that's okay. Not that it's important, but just checking.
No, it's very important. Okay, so Claude, I mean, for those who might not be aware of what your job as an astronaut has been in the past, you've actually flown on 4 separate shuttle missions, and you're the man who fixed Hubble, which means that we are able to see deeper into the universe than what humanity was ever previously able to see. And you've spacewalked, and basically, yeah, you've done all the most incredible things as an astronaut, but also in progressing what space exploration is all about, and advancing what humanity, how far we can reach, what we can see, what we can do by going out there into space. So we're deeply honored, and find it so great that you join us, and you've been joining us every year as our honored guest. And this year, there is a very important topic to talk of. It's deadline May 28. So I'll let you explain what this is all about. And it's very critical. And I think that there are many people in this particular audience. Claude, I'm not sure if you were on at the time that I mentioned who's in our audience, but they are an amazing bunch of people, really, from all walks of life, but so many professors, students, engineers. I'm not sure if you heard me mention that I think that with these particular participants that are joining us, I think we would be qualified to build a second ISS with the qualifications that, that all of them collectively have. So I think you're perfectly placed to tell us all about deadline May 28.
Okay, well, thank you very much, Miki. And before I share my screen and talk about that particular subject and a few other subjects, but rather briefly, I would like to thank you, Miki, for inviting me here. Thank you, Guido. Thank you, Tatiana's, both Tatiana's. Thank you, Daniele, for your story. And I think Thomas Z is no longer with us, but thank you also to him in his absence, and for the very kind word that he had for me. It's nearly embarrassing when you hear people saying so many positive things about yourself. But anyway, I really appreciate his very kind words to me. It's a pleasure to be here. There was a lot that was covered already. I really appreciated all of the wonderful words about Gagarin by the two Tatianas. Great statements by Daniele, and you told us a lot of stories, Guido. As usual, you have so much knowledge and so much equipment in your museum. You are a wonderful reference for all space activities, whether are manned or unmanned. And thank you very much, Miki, again for inviting me. I'm going to share my screen. Hope it will work. Oops, I didn't prepare it to the right location. Sorry about that. So I need to go to the beginning. Anyway, that's it. So ESA is recruiting a new class. Do you see my screen?
Yes, we can.
Okay. ESA is recruiting a new class of astronaut, online application, deadline May 28, 2021. Do not be late. I mean, that's the message. I'll talk about a few other things, but I think this is the main message that I wanted to forward. Write your application. Take good care about your application to be sure that there are no mistakes. I have been talking to many people in LinkedIn about the fact that take your time, fill it carefully, have it looked at by family members and close friends, and then send it before the deadline, May 28. That's obviously important. But I won't talk only about this. First thing first, we're celebrating a delayed Yuri's night. And I know these things have been said already by the Tatianas and also by Guido, but one brave cosmonaut, Yuri Gagarin, first human spaceflight, April the 12th, 1961. I will be brief again because I want to talk about other things, but I think it's so important on Yuri's night that we talk about Yuri Gagarin. I have an enormous respect for Yuri Gagarin and for the fact that he opened the doors of space to so many of us. I like this picture also so much. He was at the same time a very courageous, very bold man, but very cheerful, very cheerful. I love this picture. This is Yuri Gagarin smiling at us, a wonderful individual. We'll never forget his achievement and his kindness. But also very close to my heart because I was very involved as a European astronaut, Swiss astronaut for the Swiss in the shuttle program. And I was there since 1980 at the Johnson Space Center, Houston, to train as a mission specialist, as an ESA astronaut. And I knew John Young and Bob Crippen quite well, and I also have an enormous respect for those two individuals. It was nearly exactly 20 years after the flight of Yuri Gagarin, STS-1, the first shuttle mission, early in the morning on the 12th of April, 1981. John Young, Bob Crippen, again, two incredible astronauts. I put them very high in the scale of the qualification of astronaut. John Young had flown on Gemini 10. He was commander of Apollo 16, walked on the moon. He was a commander of STS-1, the first shuttle flight, and then he flew STS-9, which was the 9th shuttle flight, but also the first flight of the Space Lab module, together with Ulf Merbold, the first ESA astronaut to fly on the space shuttle. Bob Crippen was on his first space flight. Again, I would put them at the level of Gagarin. Gagarin, of course, was the first one, so there's no other first than the first one. But the level of courage and talent and willingness to take risk of both Yuri Gagarin and these two individuals was at about the same level. On the right-hand side, you see a picture taken in the Space Shuttle simulator. I had the opportunity and the immense privilege to be with them on a few training sessions that I had prior to STS-1, because I was there in 1980, so it was about a year before their space flight. I have an enormous respect for these two individuals. Liftoff, that was shown already by Guido on the 12th of April, early in the morning. Mission that lasted about 54 hours. Relatively short mission. The idea was to verify the capability of the shuttle to safely get into orbit, and that was not at all obvious with a vehicle that was totally asymmetric compared to all the rockets that have cylindrical symmetry, and the crew on top, they were on this space plane on the side of the external tank, and they were not at all on top in the cabin of Columbia. The ascent was a very dangerous portion of the mission. The on-orbit, as usual, not that dangerous. And then the re-entry approach and landing was also something completely new that had never been really tested, neither in wind tunnels, a little bit with computer flight dynamics, but still, I remember the entry was a very, very tense moment. We had the loss of contact for about 10 minutes. And when we heard again, John Young saying everything is fine, we were really relieved. They landed on the lake bed at Edwards Air Force Base or Dryden Research Center. It's a very large 25-kilometer long lake bed. They wanted to be sure that they had margin plus or minus, because at that time, again, we didn't know too much about the flight characteristics of the orbiter, except we had done approach and landing tests in the late 70s, but still. And that picture has been shown already by Guido, but this is very touching. When you think about it, this vehicle was in space at 28,000 kilometers an hour over the Indian Ocean 1 hour before this picture was taken. It took about 1 hour between the deorbit burn on the opposite point on the orbit versus the landing point, so it was over the Indian Ocean. So at the time this picture was taken, the tiles in the bottom were still pretty hot. And John Young came down already. This is Bob Crippen, and he's holding the handrail. And I know exactly how you feel when you come back from space. Even only 2 days, you feel a little bit shaky. So I can very well imagine what Bob Crippen was feeling when he was going down this ladder. This picture is wonderful. This is a spaceship that was a space plane, in fact, was able at the end of the mission to glide and soft land on a runway. For me, this is very meaningful also. Gagarin's flight is very meaningful, but this, having been involved so much in the shuttle program as a European astronaut, is very meaningful to me too. Okay, about 10 years earlier, we had the huge inspiration of the Apollo program, and you've seen pictures like this already. And I like this picture Apollo 15 that landed in an area that was quite rough, and you see the tilt of the orientation of the lunar module that landed in this tough area. For me, this is a wonderful picture showing also the spirit of the Apollo program, going to a place that was really tough and taking a lot of risks. At that time, during the Apollo program in the late 60s and early 70s, I was an astronomer. You see on the left-hand side, picture taken inside the Gornograd Observatory. We had a relatively small telescope, but a powerful photometer doing a multicolor photometer of stars. I was at the same time a fighter pilot in the Swiss Air Force. And I would say that both of these qualifications helped me a lot later to go through the selection in the first group of European Space Agency astronauts. I loved flying the Hawk Hunter. I flew the Hawker Hunter for 22 years, and this is a wonderful part of my career. And I learned a lot about risk management also. It was a risky mission, and I learned a lot about how to manage risk in order to accomplish the goal, which was, to put the bombs on target. It was not to accomplish repairs on Hubble or scientific experiment in space, but in a way, the spirit was the same. It was a risky mission. We had to manage risk. We had to make decisions also along the way. And that was a very useful part of my education. Selection ESA astronauts in the middle of 1978. Eventually, Ulf Merbold from Germany, Wubo Ockels, and myself were selected. This is Franco Malerba, who was pre-selected for a while. I finally flew with him later, but he flew as a payload specialist. Then we were brought to Houston and started to train on the shuttle. I must say, it was quite different than the way it is now for the new ESA astronauts. The new ESA astronaut, or whether they come from Japan or Russia or Canada, they have the International Space Station. It's a well organized system, and there's no doubt when a new ESA astronaut starts his or her training, there's I would say, a red carpet to a flight in the International Space Station. For us, at the beginning, it was not quite obvious. And I spent 12 years between arriving in Houston in 1980 and my first flight in 1992. But after that, there were 3 other missions in a rapid succession, 92, 93, 96, and 99. But you had to prove yourself as a non-American involved in the group of American astronauts with a Texan management at the Johnson Space Center. You had to prove yourself before getting there. Anyway, that was the discovery of the space environment. We had a tough time with the tethered satellite, which you see here. 7 crew members, including Franco Malerba and Marsha Ivins, woman American astronaut. And you see this picture was not taken in a simulator on the ground, but in space, you see how long hair behave in the space environment. That was my second flight, the first servicing mission of Hubble, a wonderful picture. That was, for me, my best mission, although I didn't go out in spacewalk, but the spirit of the mission was absolutely wonderful. We had a huge problem with Hubble, an optical problem, a problem with the solar rays also, and we had to fix these 2 things, plus a number of other things that we took care of. We are above Australia, 600 kilometers, Antarctica in the background, Story Musgrave with the tools, and I was commanding the robot arm to bring him to the proper location to do the job, and Jeff Hoffman in the cargo bay. Wonderful mission. I had the pleasure of going back to Hubble 6 years later on the 3rd servicing mission. This time I'm spacewalking. I'm here at the end of the robot arm, replacing fine guidance sensor number 2. That was the one that was defective. We replaced it. We replaced the main computer of Hubble also, together with Mike Fall, whom you see here. You see the size of Hubble, huge telescope. I know the James Webb is going to be even larger than that, but still, that was a big machine already. Okay, European astronaut. That was the European Astronaut Corps in the year 2000, shortly after I had flown my last mission at the end of 99. We were too many, but that was a time when all of the national astronauts, mainly from Germany, from Italy, and from France, had been recruited inside the ESA Astronaut Corps. So you had the original Astronaut Corps, plus a few that had been selected in 1992, plus all of the national astronauts. And that was a large group, in fact, larger than what was really needed. Too many. Now, this is the astronaut corps of 2021. We have the 6 that were recruited in the last election in 2009, plus 1 German citizen who was recruited a few years later as one of the finalists of the selection of 2009. He was picked in order to add 1 to this group of 6. So there are 7 ESA astronauts now who are qualified for mission to the International Space Station using either the Soyuz to go there or more recently the Crew Dragon. Now, these are some pictures that I collected from the missions of my colleagues. Current ESA astronaut from the group of 2009. You have 2 pictures of Luca Parmitano, Superman, Samantha Cristoforetti from Italy, the only woman that we have now in the ESA astronaut corps, and Alexander Gerst on the spacewalk. Most of them performed, not all of them, but a few of them performed spacewalk. Alexander Gerst and Luca Parmitano, as you know, he was very instrumental in doing repairs on the alpha magnetic spectrometer in late 2019, early 2020. And Thomas Pesquet also spacewalked. And by the way, this picture has been shown already, but we have a crew of 4 that will be going on the 22nd of April in 1 week from now, including Thomas Pesquet, who will be doing his 2nd flight. That's the commander and the pilot, and the Japanese astronaut will be joining. So in 1 week, Crew Dragon on top of the Falcon 9 inbound to the International Space Station. At the time they will arrive there will be 11 people on ISS. The 4 that came already with the Crew Dragon lifted off in mid-November last year, but they are still there, 4 crew members, plus the 3 that went up with the Soyuz not long ago. So there will be 4 plus 4 plus 3 will be 11 for a while. Now I come to the to the real subject. ESA simply needs more astronauts. We have seen that there are too few now, only 7. And starting the new recruitment now, the recruitment has started already. The online application has started at the beginning of March. It's time to apply. Don't wait. Deadline for online application is May the 28th, 2021. Most of you will be a little bit older than this young astronaut here, but the maximum age is 50, so it's quite a bit higher than it was in the past. Now, I'm not going to go through all the details, and you can find this online. I'm sure most of you who are interested have found all of this online already, but these are the requirement to apply. Very briefly, you have to be a citizen of one of the ESA member states, 22 member states, and here I talk mainly to Swiss, but also to some others from other nations. Master's degree or higher in natural science, or engineering, mathematics, computer science, and for the first time, they also accept experimental test pilots. There are very few, but there are some, and that has been added to the basic requirement that we had until now. 3 years experience, professional experience after you obtain your master's level, and also as an experimental test pilot after you get your degree, you need 3 years experience in the minimum, very fluent in English, strong motivation, flexible with regard to place of work, obviously. There's training in the US, training in Russia, training in Canada, training in Japan and in Europe. Calm under pressure, that's pretty obvious, and willing to participate in life science experiments. One point is not mentioned here for the ones who apply online now. You need to go through a medical check corresponding to what is needed for private pilots. It's a class 2 medical check, and in Switzerland, you have to go to one of the medical doctors who is approved by FOCA, Federal Office for Civil Aviation, or BATZL, Bundesamt für zivile Luftfahrt. There is a list of such doctors on the BATZL website, so you can find this easily. But before the 28th of May, if you apply, you need to go through that medical check and prove to ESA that you are in pretty good medical condition. And these are all the steps. Then there is a screening at the end of this year and the beginning of next year, psychological and cognitive test and knowledge test. Medical selection will be in the spring of next year. Then there will be a round of interviews until appointment and announcement at the end of next year in October 2022. The mission, I won't go to the detail, but there will be mission with ISS, of course. This is for all robotic exploration and human. So this is robotic and human, but there will be, of course, mission to the moon, to the gateway, and at some point to the surface of the moon. And eventually there will be mission to Mars also. But this is here representation of the robotics mission to Mars. These are the spaceship that you'll be using, the Soyuz, the Crew Dragon, the Atlas V with the Boeing Starliner on top, which is the alter ego of the Crew Dragon on top of Falcon 9 of SpaceX. And of course, at some point for the flight to the moon and Mars, it's going to be the SLS, and maybe Starship of SpaceX also at some point. To the International Space Station, that's not International Space Station, that's another station. And the station is not exactly like you see on 2001 A Space Odyssey, which is a wonderful station. A station is more like this. But there's work being done there. A lot of cables, a lot of computers, a lot of work, quite a hard activity program, not only in the scientific field, but also fixing whatever goes wrong in the station. It happens sometimes. There will be opportunities for spacewalking. And if you do spacewalk, don't do what Tata and Captain Haddock are doing here. Try to always hold the structure, because just relying on the safety tether is not a good idea. That was okay for Hergé on a marché sur la Lune, but don't do something like that. But you'll be going spacewalking. Spacewalking is a wonderful experience. There will be flight to the moon, as mentioned already. This is the Orion capsule, and with a service module that is designed, built, and delivered by the European Space Agency. So ESA has really a foot into the Artemis program and the flights to the moon, not only on the gateway, which will be the case for the early flights of Europeans on the Artemis program, but someday on the surface of the moon in the South Pole, because that's where the base, the human base, will be established on the moon surface. Some point to Mars, either walking or going with pressurized vehicles. And someday maybe you'll go to other destinations like Mercury, although it's pretty hot in Mercury. We may not go there, too close to the sun, or to Titan. You see some astronauts here on Titan with a wonderful view of the planet Saturn in the sky. These are dreams, but we have to work with dreams. And it's time to apply. Without delay, good luck. And never forget Yuri Gagarin. Thanks for your attention.
Thank you, Claude. Thank you so much. Okay, so now we're getting pretty short for time, but your talk was a perfect introduction.
Yeah, we have 0 minutes because it's yes, 9 o'clock exactly.
Now. we actually had some extra time from Thomas, which we weren't expecting. So
it was wonderful, though. I think it was time well spent with Thomas. There's no doubt about that. Yeah. I should have been shorter, but I had things to say.
Yes, we should have known, and we should have accounted for extra time for you. So now we actually have a panel with our aspiring astronauts. So Claude, we'd like for you to stay with us because I mean, we see you as rather a mentor for the others. So I'd like to introduce, perhaps first I'll introduce Christine, who is, she has a very, very busy schedule. So I really have to apologize for definitely for her, and I am trying to find her. It's so amazing on Zoom. Okay, here she is. This is Christine Corbett Moran. She was, back some lifetimes ago, her and I were friends back in Zurich when she was studying here. But Christine, Christine has impressed me ever since we first met as somebody who is ascending into realms of professionalism and competence in all sorts of fields. And from when I knew her as an astrophysics PhD student at Zurich, she's now there at NASA, a colleague of Dr. Zurbuchen's. And where he said he was a leader, I would say that Christine is one of the doers. She's the one who's actually busy making the work happen, and she's actually straddling a couple of jobs at the moment. In fact, probably Guido and I would like to apologize that we could have actually brought you in for almost every single talk that we had on already, because we would have loved to ask you, oh, and yes, what's happening, because you're on the ground at the moment. You're up at nights working with the rover and directing the teams. So perhaps I should stop talking and let you introduce yourself just in a couple of words, and then I can introduce the other two.
Thanks. And thank you, Miki. It's really an honor to be here and with such esteemed guests. I'm so glad they went over, because I'm happy to say just my two little pieces. I'm also an aspiring astronaut here on the US end. I'm an American citizen. I did my PhD at the University of Zurich in Switzerland. So I do have, you know, a special place in my heart for Switzerland and the Swiss space industry and the ambitions. And I hope, you know, we get at least one Swiss astronaut, but I say, why stop there? You know, so dream for space. And I'm here kind of to answer, you know, maybe points of comparison or any questions about the US kind of process. I went through the last round of applications and I got into kind of the final 50 and saw some of the friends that I make in that process actually be selected and now selected for missions. So cheering them on. And of course, I'm applying again and always dreaming of going to space. But in the meantime, doing a mix of leadership and, you know, on the ground work at NASA. I'm on the Mars Perseverance Engineering Camera Operations team. And I'm also the Deputy Director for the Exoplanet Exploration Program. So.
Okay, well, congratulations. And you have to know something, that some of the best US astronauts went through several applications. You know that very well. So
I do, and I'm so excited with, you know, all the new opportunities from commercial space for, you know, hopefully having bigger and bigger classes where there's just so many different paths for space around the globe.
Yeah, because there's not only NASA or ESA astronaut, but you can be an Axiom astronaut or SpaceX astronaut or Boeing.
That's right.
And maybe in Switzerland, you can be an ABB astronaut or RUAG astronaut, who knows?
Yeah.
Well, congratulations and good luck for the next steps. I'm sure you'll make it at some point, Christine. Good to see you.
I hope so. I hope so.
Every year she becomes more and more collects more and more qualifications to make her an ideal candidate.
Well, you have to look at, you know, Claude's resume, Story Musgrove's resume, you know, all these people's resumes, and you just, there's no amount of qualifications that even, you know, ever stacks up. So that's one of the great things, is that it's always an adventure along the way, whether or not you make it to space, because even the process of doing all these kind of space related, you know, empowering, inspiring, it's all part of the journey. And, you know, whether or not you end up floating in microgravity, that's just one small part of it if you consider a lifetime of space. And then of course there's life after space as well. Yeah, that's just one part on a giant hike in the Alps. So.
Well, that's exactly why we'd like to introduce the next guest. This is Christian Cardinaux and also Eleonore Poli. I have to find, here is Christian, and I need to find Eleonore.
Find me.
Hi, everyone.
Yes, where are you? Why don't I see your video? There you are. Okay. So Eleonore is both Christian and Eleonore are analog astronauts, and we figured that not everybody might be aware of what an analog astronaut is. So both Christian and Eleonore are going to make a little presentation to explain what that is.
So give me a second. I'm going to try and share my
only a couple of slides.
Does that work? Okay, so you probably can see my screen, I guess. Wonderful email. This is great.
Yeah, we can see it. Nice picture.
So can you see this? And from the start. So as you see, can you see my whole screen, or is zooming
yep.
Yes,
looks great.
Perfect.
Perfect. Okay. So thank you so much, Miki, for having us, and Guido for inviting us. And it's really an honor to be all there together. Just want to say Yuri is really important to me, and I think probably to a lot of us, because he's really allowed to open doors to space. And what Christian and I are trying to do is we're trying to replicate what an analog space mission is. What a mission is in space by replicating it on Earth. So we're trying to simulate basically a lunar base. We do trainings in extreme environments. So we did some diving, etc. I'm going to show you a few pictures. But basically the way it started was the following. It was in 2019, so this is 2020 application, but in
before COVID.
Exactly, before COVID, I saw something on the Swiss Space Center, which is now Space Innovation, saying, do you want to become an astronaut? And of course, I wanted to become an astronaut. And basically, Astronaut is a mission that is made by students, for students. So I'm a PhD student in material science at the University of Cambridge. I studied at EPFL before and then Zurbuchen. And I was in Cambridge when I actually saw this and applied, and we go through the four stages selection process. So you first have the usual CV, motivation letter, and they also check if you haven't done any criminal activity. And you then send like a video of you, so you show how you speak English, like what is actually your motivation? Are you here just because you want something nice on CV? Do you actually enjoy being in a tin can for a week? And then we did also psychological and logical and just kind of, just cognitive tests. And then we had a wonderful interview with Claude Nicollier, and it was one of the most exciting moments. Like, oh my God, it's just worth it just to have an interview with Professor Claude Nicollier. And also with the whole team has been fantastic. And then we did group tests to see how we fit in. And now, so I'm commander for the crew, and so far it's been absolutely amazing. And I think Christian would like to maybe say a few more words about the crew.
Yeah, so nice to meet you. I'm Christian, 26 years old. Actually, I saw the little poster looking for an astronaut while I was in Space doing my internship, and now I'm working there on a photobioreactor that is due to fly on the ISS in 2026, hopefully. So that's pretty exciting. And I also work at a startup, the Countdown company, and I'm an analog astronaut for the mission. So Asclepios mission, quite exciting actually. The goal is to have 6 people in this tunnel base in Grimsel for 7 days, mimicking a moon base with the experiments. And this is quite exciting. So you can see actually the whole crew. So we are 6 analog astronauts, 2 backups that will act as Capcom during the mission. And it's quite an amazing team. That's the most, the greatest thing that happened, I guess, was to be able to work with such passionate people about space.
Do you want to comment on the diving? I'll do it.
So I'll go with the diving. That was a quite an experience. We went for 3 days in Crans-Montana, and with a Nordic explorer, Alban Michon, which specialty is to dive under the ice. That's quite an experience to live. So we also went under the ice scuba diving with some red light during the night. And it was quite amazing because you can feel like less gravity because of the water. And with the red light and the bubbles going up and stuck under the ice, feeling like a bit of mercury, you could really feel like you were on another planet. So if you have the chance to go night ice diving, I will really strongly advise you to do so.
And this is when we did the dress rehearsal. So one of my favorite sentences to describe an analog space mission would be, we fail on Earth so that we succeed in space. And the dress rehearsal is you fail before the analog space mission so that you succeed in the analog space mission so that you succeed in space. And basically the dress rehearsal was 48 hours. We were together, not in a bunker, not in a tunnel, but actually in a room at EPFL underground. We had to request every time we wanted to go to the bathroom, every time we needed water. We had to check how much food we were getting and what we were eating, what we were doing. We had a tight flight plan. And what is extremely interesting is your brain rewires really quickly. I don't know, Professor Claude and Collier if it was the same for you when you went to space the first time. But for us to have a tight flight plan, to have people telling you every hour what you do and how you eat, for me, I found it really amazing because it allows you to optimize the things you do. Like, you save a lot of time because you don't have to think yourself how you're going to organize your day. However, when I came back to Cambridge the same night, I was on the phone call and almost requested an EVA to go composting, which for us meant going outside to go to the loo. When I realized I did not need to do that anymore. And the next day I did not need to ask what kind of food I was eating, nor to look for the number of it. So here you see a few things. We did an experiment. We're trying to actually get radio waves, but actually it wasn't really working in the bunker. We were taught Russian by one of our astronauts, Sebastian Ogade, who's from Chile, but actually lived in Russia for about a year and is now living in Torino in Italy. And we have two astronauts here who are mountaineering fans. So we have Manuela Rambo and we have Willem Suter, who were teaching us survival skills for mountaineering. And here you have the wonderful MCC. So I don't know, Christian, if you want to say a few words.
Yeah, sure. So basically with the dress rehearsal, it was pretty much quarantine for 2 days with people looking at you. That's how I would describe it. I don't know if some of you guys went to COVID quarantines, but they can be pretty intense. And for the dress rehearsal, you have the MCC supporting you. So the goal of the MCC was basically to check that the experiments were going well, doing all of the recording, and keeping a nice contact with the astronauts. So I was Capcom during that time, so responsible of all of the vocal communication, and it was quite interesting to support people without physically being with them, but you still feel very much connected. And we didn't have any delay because we were not that far away. But I guess one of the challenges will be for Mars that there is some delay. So no direct vocal communication will be possible, I guess.
Exactly. So analog space missions, in my opinion, are very important because they really allow us to first see, are we ready to be partly astronaut? Obviously, it's not as hard. The section is not as hard. The condition is not as difficult. You know, there's always an emergency exit, which you don't have on a spacecraft. However, it's really great because as students, we don't necessarily get the opportunity to become astronauts right away. Some of us are a bit too young for the selection coming, or we might never get to do it, but we can still contribute to space exploration by creating analog missions and really trying out some experiments that will then be used on Mars, on the Moon, or on the ISS.
Yeah, and for me, it's really a great opportunity to work with such amazing people that are almost, that are so passionate about space. It's always fun. Like, it's a great adventure. Would highly recommend anyone that wants to be an astronaut to go to an analog mission.
Thank you. That was amazing. I mean, and so I like analog obviously is for meaning analogous as opposed to not the opposite of digital. But Christine, I mean, you've also done such extraordinary personal missions, like you wanted to go to Antarctica and it took a couple of attempts and you got there. And so like, I see that all of you are slowly building up the experiences that make you qualified to become astronauts, because all of you are quite serious about becoming possibly candidate astronauts in the future. But I'm also aware that Claude, he mentioned in previous years that, Claude, you didn't set out with an ambition to become an astronaut. You mentioned it also in your presentation that actually you just happened to have a lot of the ideal skills, being a pilot, being an astronomer. And then when the opportunity to join ESA came up, you said, yes, this actually matches perfectly. Whereas Christine, Christian, and Eleonore are really kind of aspiring toward the hope of becoming qualified and being able to be an astronaut. The three of you, as opposed to Claude, have you always wished to be astronauts, or was there some point where you were triggered to realize, actually, this could be a real thing and I'm going to try to go for it. I'm going to collect skills that would make me useful?
Maybe I'll go first because I think I probably have a combination. During my PhD in Switzerland at the University of Zurich, I remember kind of 2 selections, well, now 3 selections ago of the astronaut candidate class in the United States, seeing the call for that and kind of just it tweaking in my brain how much I loved adventure, and I had been scuba diving since I was, 16 and traveling the world, and I loved public speaking and science and space, and how this could be a potential career path for me. It wasn't something that I had a dream, since I was a little kid or since high school. It was just I had gone about my life and then come to this point where I thought, oh, wait, I meet all these qualifications. And not only do I meet the qualifications, the minimum, of course, who's selected is much more than the minimum qualifications typically. But were I to be selected, it would be really a dream career combining all these unique aspects, these facets of my personality and life goals. So it was kind of that moment during my PhD when I really said, oh, I would love to continue to keep my options open. And that first time I applied, I got a postcard rejection back, in the mail with everyone else after they had already announced the candidates. And then the next round that I applied, I got to travel out to Houston and do all the medical tests. And I ended up getting, a personal phone call from an astronaut giving me the rejection and, a personal letter from the head of the committee that crossed off my, form written name and wrote Dr. Christine, So it kind of was that moment where I realized, hey, I could really continue to aspire to do this and continue to go around, in my daily life doing the things I love doing. And, if it makes sense and it happens for me in my lifetime, fantastic. If not, I get to be here and be a part of the story. When I was rejected from NASA at the time, the second time, that personal rejection, I was working at Caltech and I thought, hey, I can still work for NASA. I don't have to be an astronaut. So I applied to NASA JPL and then started my career at JPL. So there's a lot of ways to be involved in space. And astronaut is kind of the face of the team, but it's a team. So
I do remember when you shared those rejections, and they never felt like, oh, that's the end of the story. It was like, she got further, she's it was more like a celebration or a recognition that you're stepping it up every time.
Well, in a way, that's one difference in the US and in Europe. In Europe, we had selection every 15 years or so. There was 1978 when I was accepted. The next one is 92, then 2009. But from this selection on at ESA, they say they will have more frequent selections of maybe fewer people, maybe 3 to 4, but there will be more opportunities. In the European system, if you missed one, there was no way you would make the next one because just 15 years later. But in the US, I know I know so many of my colleagues, very close friends, NASA astronauts who tried several times. And as I mentioned before, and I'm serious about that, among the best. They tried several times and finally they were received, because after so-called rejection, the term rejection is not a good term, but you didn't make it in a way. You steer your activities and you learn new things and you exercise. You get into new activities like scuba diving or parachute jumping or mountain climbing, which I think is a very good training, where you need you have a clear goal, which is to get to the summit, but there are a lot of circumstances that you can't get there. So that's a very good mental training. You do these, and then next time you are better off, and maybe it's going to be another time, and then you'll be one of the best.
Yeah. Christine and Eleanor, how about for you?
Yeah, for me, basically, thanks to people like Claude and Yuri, it was a long life dream, but also maybe a mindset, like, but not regarding maybe being an astronaut, but more of an explorer. Like since little, I remember that if you put me somewhere, I had to see and to go and to check what is after after the hill, after the forest, after the mountain. And I guess the final frontier is up there. So I guess, yeah, curiosity and the will to explore, and that passion is being fueled by people like Claude and Yuri and all of the other people that we heard today.
Yeah, I think I have the same idea as Christine, is that even if you're not selected as an astronaut, it's not the end of the world. Space there's so much you can do in space. There's so much we can, it's a teamwork, you know. That's one of the greatest pleasure that we have in Asclepios, is that we work together, and we work also for basically other teams, right? We work for projects for NASA, for ESA, and that's the point, is that you all in this together, even if you're not in space. And yeah, obviously I do want to sit on a rocket filled with lots of fuel that could blast off, but well, I want it to blast off, but not blast up. But yeah, obviously, like, you don't just go there to become an astronaut. Astronaut is obviously the cherry on the top, and I would love to go there, and obviously I would be sad not to, but I would be like happy if I know people who are extremely qualified are taken and go there. And if I were to be in mission control and to help one astronaut guide his EVA, you know, that would be one of the best rewards ever. Or if I know that one of my experiments is on a spacecraft and going to Mars or to the moon, that would be already good enough. But obviously we train for it. But for me, it wasn't a lifelong dream. I thought it was only for superheroes. I mean, Claude Nicollier said such a high example, you know, you don't think you can reach that. But the point is, if you're already taking the steps just by leading your life in that way, if you do diving because you like it, if you fly because you like it, if you do science because you like it, then you're already ahead, right? You already love that path. So the rest is just, you know, tuning it so that the circumstances lead you to become an astronaut. And there's a little bit of luck in that. We just can wish for that.
Claude, I was wondering about your reflections on, as you said, the long space between the opportunities to apply in Europe versus in NASA in the US. Do you think that this would change the shape, change the character of the kind of people who will apply? Or that there's something for us to consider for anybody who's aspiring to become an astronaut?
Well, I don't think it changes a lot. It's just that in Europe, we don't have any means of taking people into space. We could have had it with the Hermes program related to the Ariane 5 program in the early 90s, but Europe decided not to do it because there were a lot of technical problems with the development of Hermes. And finally, there was not a need for a very large number of astronauts. You know, we had this very large group in the year 2000, just after my last flight. We were too many because there was a recruitment, which I think was a very good idea, because vis-a-vis the ones who take us to space, whether it's the Russians or the Americans, it would have been annoying to have a, you know, British astronaut or French or Dutch instead of just a European astronaut. So the idea was to clean up the group of astronauts in Europe so that we have one core only. But you know, I personally did not experience this long time between selection because I just happened to be selected, fortunately, on the very first slot. So for me, then I was with my head down in the job, and I loved it. For me, the privilege to get there to Houston in 1980, 1 year before the first shuttle flight, and leaving Houston in 2007, a few years only after the end of the shuttle program. So I experienced nearly the whole of the shuttle program, which is a wonderful program. I talked only for a short time about this, but you probably have felt that the STS-1 was for me something absolutely magnificent and wonderful. And the courage of John Young and Bob Crippen was unbelievable for me.
Yeah.
So I was very privileged. You know, I did not experience this tension of the long duration between one selection to the next, like being refused in 92 and having to wait until 2009. I did not have that problem. Yeah. But now, as I mentioned, that's over because ESA will recruit more often. I think they need to do that because I like the American system where even if they recruit less astronaut on each time than in the US, if somebody misses one selection, you want to give him or her a chance to be successful on the next one.
Mm-hmm. Yeah. So I'm very conscious of the time. We've run very far, like we're 25 minutes over time, and particularly for Christine, she has a heavy schedule at the moment. She's working nights on the rover, and she's been specially sponsored to be here, and so we really appreciate the extra time. Guido, I want to quickly ask you if there are any questions from the audience to ask the panel. We can squeeze in maybe one question, but otherwise I think we'd like to reach the end of the event, because otherwise really people we're already starting to lose a couple of people, I think, because we've been running so far over time.
Yeah, there is a lot of chats going on. There are not many questions for the moment, but somebody said when Claude talks about wonder and awe, it definitely creates a lift. The overview effect is real. So I think this is really, really nice. And some people had to leave. They said it was wonderful. So and somebody tried to get another astronaut. We don't have an answer yet, so maybe we stay together afterwards and we have the possibility. It's just wonderful to listen to you all, and I really think there might be some future astronauts in this panel.
Oh, definitely.
I really think so too. And by the way, I think having been or being an analog astronaut puts you in a very good position for a selection for a real astronaut selection, because you go through a lot of the steps that are very similar. So that's an excellent preparation. And I'm sure in the interviews, if you say, I participated in Asclepios or some other analog astronaut mission, it will give you a lot of points upwards. So that's very good.
I think so.
Now I'm going to have Tatiana join us, and Daniela. Where are you, Daniela? There you are. Okay.
By the way, I just heard that Dion Stafford will be with us in a few minutes. So
who you said?
Dion Stafford. So she will join. So for those who want to be with us and ask her some questions, just stay here. Just wanted to say that.
Okay. So yeah, we've now reached the beyond the end of the event, and we want to thank all of you for joining us, and it's been a real pleasure and an absolute honor to have all the amazing guests that we've had. And I wish that we could actually have much more time to speak to each one of you, because I know that with all of them, with all of you, we're just skipping across the surface of all the incredible the stories, the skills, the in-depth understanding that you all have, and I really wish we had more time to explore all of them. But we hope that for the audience that you've had some delights and had a few more new perspectives of space. I know that, I mean, I'm not like Guido. I am not a complete space nut by any means, but every time we hold this event, I learn so much. And I am so more and more impressed with humanity and what we do and what we strive for. It brings benefits to all mankind. And so this is why I hold Yuri's Night every year, because there's so much to be shared. So much experience, and really everybody's putting their best foot forward when we try to head out into space. So it's been an absolute pleasure, but before we go, there's a couple of things I want to mention. Guido, of course, has been absolutely incredible in this journey and in putting this event together. So he and I have been spending many hours working on this together, and we didn't have a sponsor. So this has all been just with the two of us putting together whatever we could do. But we did have some donors, and I would like to mention them personally, because we are so grateful for the donations that were made. Particularly Gerard Bolle, There's Karen Ayokona. I hope I'm pronouncing the name correctly. Joel Delim, Claudia Krumnacher, Max Wolfram van Husting, Philip Studer, Moritz Bartoldi Weber, Dario Mada, Maximilian Kran, and all of them. Thank you so much. It really has made an impact and a difference, and we just feel so honestly, every time we saw another donation coming in, we felt very loved. So if you like the event that we created, there is a way to donate via the Guido's Swiss Space Museum. I think, Guido, you've already put the link there. In any case, you'll find it on the Yuri's Night page and the Swiss Space Museum page. So we will close off this event in just a moment. But after that, we will actually leave the chat open for a few more minutes, because we missed the opportunity to meet everybody face to face, which is such sadness to miss that, because you are such an extraordinary audience. I mean, you know, I see, you know, Professor Ben Moore's face there, puffing away on his paper.
Yeah, very Spen.
He is there.
Oh, yeah.
I mean, like, really, so many of you are such extraordinary people. I feel honored that you're in our audience. Really.
Here is.
You know, you're trying to find. Yeah. So Guido, maybe you have a few words. Oh, sorry. As I was saying, we'll leave the chat open. Just so that you can exchange any messages, because I see there's been quite a few chats, people asking for information. And actually, I thought you are right now connected with a lot of people with an amazing amount of knowledge. So feel free to ask your questions, exchange contacts, ask questions of the speakers who are still on. So Guido and I will shut off the video, but we'll leave the chat open for, let's say, another 5 minutes, so that you can exchange whatever you like there.
Miki, sorry to interrupt, and sorry for everybody else that wanted to speak. I'm talking to Dion Stafford right now. She's having trouble launching the app. Am I correct in assuming she needs to have the Zoom app installed on her computer?
Yes.
Okay, she's saying to me, I have it, but I'm technically impaired.
You might be open to open it in your browser normally. It should say, like, open with your browser.
Okay, if she clicks on the link that I've sent her, that should work in her browser.
Yes, we will admit her to the session.
Okay, just so everybody knows, Dion Stafford is Tom Stafford's daughter. Tom Stafford was the commander of the American team of the Apollo-Soyuz test project. So I've been working all night to get somebody. So thank you for your patience. Sorry, it's the last minute. Hold on.
No worries. And by the way, for the rest of the audience, this is Dwight, who is actually the gentleman who created the Skylab documentary movie.
Yes.
Yes.
No, that's right. That's me. That's me.
It's an excellent film, and I'm sure everybody in this audience would enjoy seeing this film. So I highly recommend it. Dwight, put your details in the chat, and let's
what everybody needs to have in their collection is this, right? That's the Blu-ray of Searching for Skylab. We interviewed pretty much all the living Skylab astronauts at the time. That was in 2017, of which, sadly, a lot of them are no longer with us. So you get the most comprehensive detail of Skylab in a film form that you will find anywhere. Went to great lengths, you know. As you can see, I live and breathe Skylab. So as you saw, Miki, when you looked at my qualifications, I said Skylab, the whole Skylab, nothing but Skylab. That's my qualification. So if you have any questions about Skylab that aren't too technical, because, you know, I don't know everything.
This is Dwight. You can ask him in the chat.
Yes.
Absolutely. Love to hear from you. I have had some truth serum, so be warned. You might get a bit more than what you bargained for.
Okay, so Guido, please.
Yes.
Last words from you.
I also wanted to thank all the guests, of course, and all the participants. It was a pleasure to have you here. And I have one more slide I would like to share with you.
Oh, yes.
I think somehow
slide
it's really fascinating, because you see here two space travelers that are very important, and if you look at them, they could be brothers. It is, of course, on the right side, it's Yuri Gagarin, and on the left side, it's Neil Armstrong. And they really, really look like brothers. So this is my second last slide. If you, Miki already mentioned it, if you want to make a donation, we appreciate it very much, of course. I will post the link again in the chat afterwards. Thank you all for being with us, and it was a pleasure to have you here.
Thank you. Thank you, Guido, and take care, everyone. Thank you so much for joining us.
Thank you so much for the opportunity. Lots
And
of
I would like to wish all of the young men and women who want to become astronauts that they do become astronauts and they join the family. It's a wonderful family.
Thank you, Claude. Okay. Good night, everyone. Take care.
Bye-bye. Thank you.
Thank you so much. Bye.